I grow.
You guys like that. Or that's one whereas like you can get like strength. And see those like the black sleeves. It says if CFK never that's so bad and AFK is great, let's see with it.
Oh.
You know, like you got a black all on it.
So let me just highlight the calendar for a second here. So we're going to go through our quiz review packet over the course of these next or the rest of the week here to get ready for our quiz next Thursday. So we'll work on worksheet 1. Whatever we don't finish, I'll check for homework for tomorrow. And then tomorrow we'll do worksheet 2. And then Friday, worksheet 3. Worksheet 3 is a little bit longer. Just want to give as much additional practice as possible. So, and then that will be due on Wednesday after we get back from break. You guys also picked up the solution keys. So I'd like for us to work through the packet on our own mostly, but I will kind of highlight certain problems as we pace ourselves through the packet. I'm going to have help sessions. I have some additional worksheets that I can give you for you guys to pick up tomorrow. It's also on the website. On the website, it's called Additional Worksheet 1 and Additional Worksheet 2 under today's date. So tomorrow morning, 7:30, Friday morning, and Friday afternoon. And I'll go through the additional worksheet packet, or you can ask questions from review packet if you like. And then next week, I'll also do help session Wednesday morning or Wednesday afternoon and Thursday morning. Okay. So leading up to next Thursday's quiz. And it's going to be non-calculator for now. Let me confirm that with you over the course of this week, whether it's non-calculator or but right now I'm going to say the problems I'll give you is going to be non-calculator. Okay. So let me start off with this here. I think it seems a little daunting looking at a problem, and there's so many different tests. Like, how do we know what to use? And so I try to put things onto a sheet where there's certain properties that can kind of give away as to what tests could be a good fit for that. And so I want to kind of go through that to begin with. So I would say the first thing that you want to do is do the nth term test, unless you're absolutely certain that that you can recognize it as a different type of or a specific type of test that you want to use, like geometric series or piece series. Those are easily identifiable. You can jump into that. But one reason that we want to go through nth term tests first is because there are some problems that you can do using limit comparison test, and you can do using ratio test, and it will get you the same result. But if it's a diverging series, then sometimes nth term can just get you to the answer in half the time that the other test can give you. So want to kind of get into a habit of just going through nth term first, because it only takes a short amount of time compared to other tests. So that's so not because nth term test will solve it and the other test can't solve it. It's just you can sometimes reach your result faster with nth term test, especially if it's a diverging series. Second is I included this. I just found this one here, so I want to put that, have you guys add that. Okay, so first start with nth term test. The second is, does it look like a geometric series test? Does it look like a ratio raised to the nth power? Sometimes geometric series test is kind of hidden in a form like this, but you can kind of see yourself kind of rearranging this into a coefficient with a ratio, a ratio constant raised to an nth term, nth variable. And that's also a good candidate for a geometric series. These are usually pretty easy, I think, to spot, geometric series. P-series are also easy to spot because you know it's going to be a n raised to a constant in the denominator. If I have an n raised to a constant in the numerator, then I want to go through nth term test and use that. Most likely it's just going to diverge. But P-series tests and geometric series tests, these are, I think, pretty easy to spot. Okay. Integral test. Integral test, the way that I go about thinking integral test is, does it look like a U substitution problem? Okay, if it looks like a U substitution problem, then that usually is a good candidate for integral test. So in this case, this is a good candidate for integral test because what could be our U value here? Natural log of n. Yeah, so maybe I would rewrite this as in terms of x just to make it easier for me to recognize. Right, and then the U value will be natural log of x. So if it looks like a U substitution problem, then typically, I mean, you always want to go through nth term test first, but hopefully we're able to look at a problem and kind of identify that, oh, wait, that looks like a U substitution problem. Maybe integral test would be a good one for that. Okay. Next is something look like a good fit for a limit comparison test. And the way you can tell is you have rational functions in this form here. This one, I can just find a comparison partner pretty quickly, 1 over n, and then go and see if this will diverge. Okay. I do want to point out something though, is that sometimes you may look at something like this and think, oh, okay, this is limit comparison test. I want to jump to that conclusion. But what if I had a problem that looked like this? This looks like a limit comparison test, but we really should do what first here? Nth term, right? Nth term can just quickly tell us this is going to infinity, and that saves us a bit of time. I mean, we can do a limit comparison test for this, but you know, if something only takes a few seconds, we always want to do nth term first. Okay, alternating series, I think that's easy to spot as well. You see that alternator there, and then you can tell that, okay, probably an alternating series test. Ratio test, if you see exponentials and factorials involved, it doesn't have to be both. It could be a combination of both. It could be just exponents, like what we see here. Questions that students have was, well, how can we tell between ratio test and geometric series test? They kind of look the same. So yes, that's true. They kind of look the same, but if something looks too complicated for geometric series to handle, like for this one here, right? If that n wasn't here, then I would say, yeah, let's go through a geometric series test. We can just rearrange it and get that ratio to show up. But that n kind of makes things more complicated. So my next option is then going to be ratio test. Does that make sense? Okay. Root test, I think, is also easy to spot because I have, if I can raise my entire expression to the nth power, then I can just take the nth root of that and just focus on that, and that'll be an easy root test identification there. And then direct comparison is most likely a last option. Basically, if limit comparison doesn't quite work, and I can't quite find, I can't quite get that to show up, then direct comparison could be a good fit for this. This one would be where, well, we know cosine squared n. We know cosine of n is just going to hover between -1 and 1. It's always going to be some decimal value times n. So we know that this is going to be less than 2n. So if we compare with one over 2n, we're able to see that, well, this is a p-series, harmonic series that diverges, and that this is going to be more. So direct comparison would be a good fit for this.
That diverges.
Yeah, diverges.
Would n term test work there?
I don't think so, because nth term test will go to 0, right? Well, but these two ends will go to infinity. Right. So it is, I think this will still go to 0. Yeah. Okay, so hopefully this guide kind of helps in terms of looking at a problem and not being completely lost in terms of, wait, how can I jump to the right test without having to go through all 9 of them for every single one. Any questions with this? All right, so let's go ahead and start with number 1, and then as you guys work through, I will kind of highlight some problems as you guys are working through. Share back.
It's king.
Thing I want to point out is when it comes to geometric series test, that's the only type of series where you're going to be expected to find the sum for. The other series, you just have to determine whether it converges or diverges. But geometric series, we do have the ability to find the sum. So we want to make sure we can do that. And then with integral test, make sure that once you are committed to going through integral test, make sure you state the conditions for integral test, which is positive, continuous, decreasing. Okay, so just make sure you state that condition before you jump into your integral test. You don't have to. You just have to just state it. Yeah, just state it. You know, that's you don't have to prove that. You're going through, let me know if you have any questions. I'm happy to get anything up for you.
For choice C, how did 2 root n over n become 2 over root n?
Oh, yeah, so I cleaned it up. I made it, 3 root n. We know n is the same thing as root n and root n, but I think it is.
Okay.
Yeah. Yeah. It's like, so when you're, yes, we have the geometric theory as the flow breaks. It says use the one so I wouldn't use GST those. It also doesn't quite fit with GST because that plus one kind of throws us off. But if that plus one wasn't there, then we can make it into one over square, not the m. So that's when that was that. Guys, I will go through number 7 with you in detail. So about 5 minutes, I'll go over number 7 because we haven't talked about that in great detail yet. So if you're stuck on that, just move on to something else. I'll come back to 7 with you. Thank you.
One plus one. Because that's requiring sensitivity. Oh, that's the definition for E. But yeah, that's just the definition for E. That's just one thing that we haven't gone over, but. Okay, yeah, I think.
Yeah, give me a second. I'll go over number 7 in a minute or two.
Show this they call it bring experience up to the page.
Question number 4. Is the B squared is outside of the series? Does it factor into the A sub 1?
It does. Because if I plug one in, that B squared is still part. It's just a coefficient.
Okay.
Yeah, so it needs to be part of that first term.
Okay.
Yeah. Is the root test gonna be on the quiz?
Root test is not.
It's not on the DP tab, right?
Yeah, I'll say this, root test is not explicitly on it, but sometimes certain tests can be made faster with root test.
Okay.
So I'll say that. Yeah. All right, let me walk through number 7 with you here. All right, number 7, for what value of x is this series conditionally convergent? We know that there are some variability here because that x can be any number. So we want to just find out where it's conditionally convergent. This is going to be the best fit for
ratio test. Because we see the exponent there and the other test is not gonna be able to do that for us. So we just go through our ratio test. And we want to know when is this going to be less than 1, because let's not worry about that conditional conversion portion. Let's just get into where we have a inequality showing where our potential conversion values are. So we do a sub n plus 1, replace every n with n plus 1, and then multiply by the reciprocal of a sub n. That's the same thing as dividing by a sub n. So then once we're here, we're just going to do some cleanup here. And as we do some cleanup, zoom in on this here. All right, so as we do some cleanup here, I can say x plus 2 to the n times x plus 2 to the first power. I'm going to group the n and n plus 1 together because I know that they'll just kind of cancel each other out, becomes 1. And after everything is cleaned up, I just get x plus 2, or the absolute value of x plus 2 is less than 1. Okay, are we good up to this point? So now we want to get this in with, rewrite this without the absolute value bars. So this is the same thing as saying x plus 2 lives between -1 and 1. Okay. Subtract 2 from every term to get that x by itself. So now this statement is telling us that we're guaranteed to have absolute convergence between -3 and -1. Okay. However, at the fringe, at the edge of the boundaries here, these could end up being conditionally convergent. Okay, so if we want to do absolute convergence, you just have to go to this point and then you can stop. But if it's asking for conditional convergence, you got to test your two endpoints back into your series and see if you have something like an alternating series. If it's an alternating series, like an alternating harmonic series, then you can say that at that x value there is conditional convergence. So that's the strategy there. Absolute convergence, you can just stop at this step. Conditional convergence, you're going to test your endpoints. So let's test one at a time. Well, let's test -3. So if I plug -3 in for x, I get -3 plus 2 to the nth. That same thing as -1 to the n. And what do you know about -1 to the n over n? This is an alternating series that converges. This is an alternating harmonic series. We know this is a conditional convergent series because 1 over n by itself would be a diverging harmonic series, but with the -1, it all of a sudden flips over to the converging side. So we can definitely say x equals -3 is conditionally convergent. Okay, let's test -1 here. If I plug -1 in for x, -1 plus 2 is 1. 1 to the n over n is a diverging series. This is going to stay a diverging series. This is a harmonic series diverges. Any questions with that process? And this is going to be a huge process that we're going to have to do with the next unit. So it's nice that we're kind of getting some preview into it. So we're going to talk about finding radius of convergence. It's going to be the exact same process here. So if we understand this process, I think that will kind of give us a head start into the next half portion of our unit. But any questions with this process? And this is something that I haven't quite gone over yet, so I want to make sure that I went over that with you. Okay, let's work for another 5 minutes.
Okay, I know some of these problems are telling you use integral tests here, use p-series tests here, but I want us to be able to get to that point where we can look at the problem without the directions and be able to tell that, okay, this is probably going to be integral test. This is probably going to be p-series test. I want us to be able to do that without feeling like the problem is going to have to tell me what to do. Does that make sense? Well, number 8, for instance, right? You can look at this and kind of tell, okay, this is probably going to be a good use substitution problem without my u value being 1 over n.
Okay, first one is that if you don't hear that, making those for everyone,
Okay, so your homework is to finish worksheet 1, so pages 1 through 5. I'll check that tomorrow. Okay, all right, come get your folks.